Assalamualaikum and a very good afternoon. Welcome to Program Pembudayaan Ilmu organised by UTM Library in conjunction to UTM Research Week 2022. First of all, I would like to welcome the presence of the audience in the seminar room, the Deputy Head Librarian, librarians and Deputy Librarians. Not to forget, the audience who joined us live via Facebook and YouTube. To the audience, feel free to drop your questions to our distinguished speaker via the chat box. First of all, I'm Nur HAFIZAH Hamid from the Faculty of Chemical and Energy Engineering UTM. I'll be the moderator for the session today. I'm very excited and delighted to introduce our speaker, Professor in Senior Dr. Nur AISHAH SAIDINA AMIN, or also known as Prof NASA among the UTM communities. Prof NASA is a distinguished professor at Faculty of Chemical and Energy Engineering, UTM, also the leader of a research group called Chemical Reaction Engineering Group, CREG. She started her career at UTM since 1986, and since then, she has been actively involved in the research related to biomass. While I'm looking at her achievement in the past 36 years, I'm so honored to have the chance to sit next to her, and it feels like heaven sent us to be the moderator of today's session. Today, Prof NASA has secured 62 research grants, which include the internal, national, and international levels. She has not only actively collaborated with national researchers and industrial partners, her reputation in this field has crossed the region by having close collaborations with Harvard University and Imperial College. So, Prof, how are you today? I hope you're feeling so good.
Thank you, Hafizah. I'm fine.
Okay, so for today's session, Prof NASA is going to share with us on the challenge and opportunities in biomass processing technology within the circular economy and how she carries this from lab level to prototype level. Well, looking from the title, this will be a very, very exciting sharing from her. But before we continue, some of the audience might not be familiar with the terms of the title today. So, Prof, in layman's terms, could you please brief to us what does it mean by the circular economy? Well, because we have a vast range of the audience for today, so I hope Prof will be fun to explain about this.
Okay. Before I answer your question, let me thank the library, especially Dr. Nazrinda, for this opportunity, for allowing me to be a participant or a speaker in this knowledge sharing session. Okay, back to your question. Circular economy is something like what we want to do is like a closed loop, and we don't want to have waste in our process, and so we want to use the waste, to utilize the waste and upgrade it into higher value added products. So that is the term of circular economy.
So it's kind of like another cradle to cradle application, I guess.
Yeah, it's another term, or waste to wealth, something like that. Yeah, so the buzzword now is like circular economy.
Okay, thank you, Prof, for the input. Well, without further delay, the stage is yours, Prof.
Okay, yeah. So, like what Dr. Hafizah mentioned, my sharing today is about this, how I started from lab research to prototype research. So when I was approached by the library, UTM library, asking me to share my research knowledge, so I asked her for some previous sessions, so then I looked at several sessions by Dr. J. Suman, by Dr. Yong. So they shared about drone, about the robot Machikia. So I said, oh no, I don't have any robots, I don't have any drones. So what should I share? And it took me a few weeks to come up with the title. And so I thought that probably this kind of sharing, because I think it's also quite unique that I have this opportunity to go through the research from lab scale and bring it through to the prototype level. So now the research is ongoing, and we target the research prototype to reach a TRL, technology readiness level, up to TRL 6. Okay, so and after that, during this sharing knowledge during this knowledge sharing session also, I will also share what is the plan. Hopefully in the next few years, what is my aspiration for this research.
It will be an inspiration for the young researcher, Prof.
Hopefully, yes. That's also one of the objectives of this
sharing session. Yeah.
Okay, so we can start. I have a few slides that I prepared. So could you please show the first slide? Okay, so the first slide is just like an overview. That's the title. So OSBIONI is actually ozonolysis biomass. Okay, so it's a process, ozonolysis process for treatment of biomass. And N is my name, Nur Aisyah, and Y is my student's name, Yani. So we actually initiated this research from the lab scale. Okay, next. So that is the outline of our talk. Our talk today. So it's first I will start with this proof of concept, and then next I will go to the upgrading, the design of the prototype, and then what is the expansion plan, and also then finally the future development. Okay, go to the next slide, please. So this is an overview of
the journey.
The journey of this development of the post-BIONI technology. So we started way back about 12 years ago.
More than a decade.
Yes, in 2012. So along that timeline, so we have reached a few milestones. So from the GUP grant, that is the research university grant or grant university pendidikan. So we had some lab scale results, and then after that we applied for the PRGS 1.0, and there we developed the prototype, the first prototype, and then after that we got another grant. We received another grant from ICC, that is the PRGS ICC.
Okay.
So from these 3 grants, we actually come up with like a proof of concept and also a small, what we call the prototype. So in 2019, I remember that we were told that we can apply for another PRGS grant, which is PRGS 2.0. So it's a new grant, and at that time during the COVID-19, the MCO.
That's the hardest time to say.
So I had time. Okay, that means we couldn't go out. So class was online, and there were a lot of talks. There were a lot of seminars explaining about this PRGS 2.0, and I was interested to apply. So I gathered at that time. Also, I had a few postdocs. So I gathered them and I said we should apply for this grant. So alhamdulillah, when we applied, we were successful. In 2020, when the result came out, we were one of the few. I think in UTM at that time there were only 5 successful applicants. Yes, and I think in the whole country was only maybe 12 or what. So it was nice. It was a very happy occasion to know that we were successful. But then after that, okay, so between 2020 to now, we have also we experienced a lot of challenges, but still, challenges are challenges. We look at that as also an opportunity. So that's what I'm going to share.
So basically, that's the key messages of today's sharing, right? It's kind of like a long journey. I would say it's more than a decade, and for sure, it's kind of like lots of kind of like sweet memories, bad memories, all those challenges, all those kind of thing. And I'm pretty sure that will be highlighted after this letter in this sharing session.
Yeah, you need patience, okay, for
Perseverance.
doing this research. Patience, persistence, and perseverance. And just take whatever challenges, look at it as opportunities as well. Okay, so next slide, please. Yeah, so that's the proof of concept. That means when we wanted to apply for that PRJS 2.0 grant, we were asked to show the results, technical.
So I guess it's more on the fundamental results, right?
Yes, we have to present. In fact, we have to defend. I was asked to defend in front of about, I think maybe 12 panelists. So it was quite intimidating.
I don't know if I'm the one who presenting it, the fact that even the professor feel kind of like intimidating for it.
And also I was only the only person in the team to be allowed to present, but I took along the collaborators from the industry. Okay, so next for the next slide. Okay, so this is the what we say the map for the research stage and also development stage. So initially, we look at the research stage, that means from the idea generation, idea screening, and then the concept development stage. So that is up to the lab scale. Okay, so you try also in that process. You actually get the fundamentals correct, and then try to publish. So all those milestones or all those key performance index need to be shown to the panels for them to be convinced that this project has potential, and that you can actually build a prototype. Okay, so that's what we showed, and of course, between the research stage and the prototype, we also want to see the market strategy, the business analysis. So that's where we find a collaborator from industry who help us to prepare the business plan and the strategy. So there were a lot of preparation in trying to build up a case. That means you want to submit a winning proposal. Yeah, so we had a lot of meetings. We have a meeting room. So although it was sometimes during the MCO, I remember there was some break that we were allowed to come in to UTM. So when we were allowed, so we would go to the lab and have a meeting there. Otherwise, we would do it online. Yeah. Okay, so
the
then
toughest period ever, Prof.
So from there, we tried to build up. So one of the KPIs for this PRJS 2.0 grant is that your prototype should reach TRL 6. So this is what we are doing. Next. Okay, so maybe we move backward. One step is about the idea, why we want to build this prototype. This is for biomass pretreatment. Okay, so Malaysia is a net exporter, second largest palm oil exporter. So we produce a lot of oil palm waste, and one of it is the empty fruit bunch. Okay, so this has caused a lot of management problems, causing environmental issues. For example, there are heaps of waste. Yes, EFD in the mills. There are about 320 mills, if I'm not mistaken, around the country. So this EFD usually are spent, or they just let it rot, or they send it to make it as a mulch. Or some are pelletized nowadays, but still there are ample EFD that can be upgraded. So AFB contains a lot of chemicals, like cellulose, lignin, and hemicellulose that can be converted into higher value added products. For example, like the carboxymethyl cellulose. In fact, for ethanol also, we can use cellulose because cellulose is a polymer of glucose. So, but one hindrance to biomass processing is that it has lignin. Okay, so we want to extract cellulose. So one of the methods that we propose is ozonolysis pretreatment.
So basically, that's the main prototype or the main thing that you're showing.
Yes,
is sharing, right?
Yes. Okay. Next slide, please. Okay, so this is a picture.
Wow.
Everybody knows every media knows this. So everything should be made as simple as possible, but not simple. So our process, compared to the craft lignin process, is simpler. Okay, because we just use ozone to delignify the biomass. Instead of using other chemicals, for example, like sulfuric acid or strong alkalines like sodium hydroxide.
So it's more kind of like environmental friendly also?
Yes, right. So this is why one of the outputs of the prototype is to check the techno assessment, techno-economic assessment, see what is this, whether we can make money, make profit if we use
either it's economically competitive enough to be in the market, I would say.
Yeah, right. Okay, next one. Yeah, so this is the initially where we started. So it was just a lab, and the beaker and just a vessel at that stage, stage 1 and stage 2. So then for the stage 3 is that's where we built up the PRGS.
So basically that's the PRGS 1?
That's
stage 3?
Yes, stage 3 from the PRGS 1.0, and then after we were injected with some more funding from PRGS ICC, so we upgraded that to the prototype. Yes, so we call that prototype PRGS 1.0 because that was post by me 1.0. We call that. Okay, so that's about the prototype. What it is? It is like a part that demonstrates the product features and so on. So it can range from a detailed drawing with pen and paper to a fully working version. But for us, we have the fully working version. Okay,
it's kind of like humble process, from very small like conical glass up to a prototype kind of thing.
So it's from the beaker, vessel, glassware, now come to the steel.
As a young researcher, it's very kind of like, oh wow, this is how it works actually.
Right, so that's a challenge. Okay, how to make it work from the drawing. So when we were given the grant, I also forgot to tell you that when we applied for the grant, it's the first time that during my 36 years career as an academician that the proposal budget was not cut.
Oh wow! 100% being given.
Yeah, so I don't have to complain anything. I asked for it and I got it. So when we wanted to design, we wanted to find the vendors. So it was also another challenge, especially during the MCO. Yes. Okay, we can continue. So this is, I think there's a video here. Maybe we can run. Yeah, this is how the prototype 1.0 is working. Yeah, so that is the reactor, the ozonolysis reactor. So what it does is it not only degrades the lignin, it also can reduce the color. It was brown before we started, but then we can make it brighter, like almost whitish. So that is our product we call OZCell. Okay, yes. So we have the ozone generator and ozone generator connected to the reactor, and then we have the impeller. So this has been granted a patent. Oh, yes, Malaysian patent. Okay. continue. Okay, there's also the process I'm trying to explain about it. So there's no sound, but
If you can probably explain now.
so that's the reactor. I'm saying that first we have to grind the EFB and then add it into the reactor, leave it for about, I think, 90 minutes. And we control the flow rate of ozone. And so you can see that the color of the EFB changed. This is showing that the sample has been delignified. Because the lignin is the outermost part of the biomass. So that one gives a brown color.
Oh, so it means that now when it becomes brighter or not lighter, so the lignin being removed from that.
Yeah, so we saw that. So it happening, so we got really excited.
Of course, Prof.
So this motivates us to try to upgrade it and then try to go to the commercialization. Yes. Okay, continue. So that is the product. So from the EFBs at the bottom, so the ozonated EFB shows a little bit brighter. So that's where we have about 99% lignin degradation. And but between the lignin degradation to cellulose content, we also need to have a few more steps, like for example bleaching, because in the market, okay, they like something white powder, okay, like maybe Asian also they like white skin. So we found that in the market they like something that is white, showing the purity. So from there we come up with this Ozi-Cell, the product Ozi-Cell, which is about 80% cellulose content. So that is actually the crude Ozi-Cell. So if you want to produce, for example, crystal nanocellulose, we can use starting from this crude Ozi-Cell to produce. So we check from the SEM image, so we can see the effectiveness of
this process.
The ozonolysis process. So we can see that the cellulose rosettes, if you look at the something like the holes there, so there is actually cellulose rosette being exposed. That means the lignin has been degraded. Okay, continue, please. Okay, so now is another icon. So the late Steve Jobs says that sometimes when you innovate, you make mistakes.
Yes, true.
Right?
That's so
Along
true.
the way, yes, we make mistakes. It's best to admit them quickly and get on with improving your other innovations. So when we had this design on paper, how to design the prototype. So when we tried to build it up, I mean the vendor, okay, from translating from paper to the real prototype. So it is a challenge. Just we are now in the process of commissioning the prototype. Okay.
I would say it's a nightmare to kind of like admit a mistake that we did.
So I also have heard some learned people, okay, experienced people say it's not mistake. Mistake is don't say it's mistake. So it's a learning
process.
Yeah, learning curve. So don't worry.
It's a positive way on how to look at a different angle. I would say.
That's the thing that you have to face. So it may happen, because sometimes what you think it will happen or will be successful may not be. So then you have to improvise, you have to step back and then reread or rebuild or rethink. So it's a continuous process.
That's why we need perseverance.
Yes. Okay, next slide please. Okay, so from that information that we collected from the lab scale research, we try to upgrade the design. So this is the development of the post-BIOME. 2.0. So we started around in 2021. First, we have to talk to vendors. Okay. So also we met for the first challenge is that we could not have a one-to-one meeting, a face-to-face meeting with the vendors because of the MCO. Only one company that we could meet. The others, we just contacted them. So we had the online meeting using WebEx and other platform. But when we selected the companies, only 2 replied. One said they could not participate because they have some financial problems because of the COVID, and the other one did not meet our specification. So that's one of the setback, because we have to do the re-tendering process. So it was, and at that time also office was closed, the Bendahari office was closed. So things that could take a month dragged to about 3 months. So we had to do that process, and after the re-tendering, finally, alhamdulillah, we selected a company, and then the process took about maybe 6 to 7 months because we had some obstacles also, some challenges. So we're going to show that after this, what are the challenges.
It's kind of like totally out of our control, Prof.
Yeah.
So sometimes it's quite frustrating as well to have this kind of thing happen.
But luckily also the ministry was understanding enough. So actually this project should be completed this year, by November this year, but they extended it to May next year. So we
still have time, Prof.
Yeah, so we still have time to breathe. Okay, next one. Yeah, this is the drawing. Okay, we come up with this and we shoot the vendor, and they have also we discuss, okay, what we need, okay, to how to improve the quality and make it sustainable up to the scale up production. And then there are also some uncertainty factors that we have to identify that and how to tackle, and can the technology be commercialized. So we have from the lab scale, now how we want to make sure that what we produce in the lab scale will also be produced in this prototype.
That's kind of like from technicality up till the business minded.
Yeah,
Right?
So this is the challenges that we have to deal with. Okay, let's continue. Yeah, that is the prototype. Okay, so we call it OSBIONI 2.0. So that, by the way, that trademark, okay, that one was designed by a British company, because I received the Leaders in Innovation Fellowship. So one of their what we call the collaboration with them is they could provide us with some labels or for the product, for the company. So they designed that for us. Okay, so this prototype has a capacity of 2.5 kilograms.
So basically that's for the raw material itself, or 2.5 of the product?
For the raw material.
Raw material. Okay.
So for the lab scale, we have 100 grams.
So it's a lot, like from 100 to 2.5.
Yeah. So that's we plan. Okay, the capacity about 2.5 kilogram. And now the prototype is equipped with this pedal ribbon horizontal reactor, a washer, a separator. So the prototype also is connected with an ozone unit that consists of ozone generator, chiller, and ozone disruptor. So there are two parts, the reactor part and the ozone generator unit. So this unit now is located in a high temperature lab in the Faculty of Chemical and Energy Engineering. Okay, next one. Okay, so this video shows the prototype. Okay, so it's showing there. So down here these are the washers and also the evaporator. So the reactor is actually at the top.
Oh,
So, yes.
So basically, it's coming from the top down to the
Yes,
bottom.
yeah, we use the gravity to bring down the product. So our main product will be the OZ cell, and we get the side product which is called OZ link, the lignin. So lignin itself is useful. So we have other researchers who are going to use it. Probably Dr. HAFIZAH and
Hopefully soon.
Dr. Asmadi. So they will be looking at the lignin, and for our group, Dr. Amnani, Dr. Yani, and myself, we're looking at the cellulose part. Okay, continue please. So this is the prototype development stages. Maybe this is just for sharing. So we have to have the concept design from the lab scale. Just now for lab scale, maybe you saw only the ozone generator and also the reactor. But now with the prototype, we
bind it together.
Yes, we have to include also the washer and also the evaporator to recycle the acetone and so on. Okay, and then selecting the company. So this is also very, very.
That's your major hurdle before.
we don't really know before because we're just a researcher. But now you have to find the companies, and then so this is very, very important. So that we want to make sure that the prototype is designed and then it's built as specified by us. Okay, and the procurement and fabricating and delivering the prototype. So now the prototype has been delivered, so we have to commission.
So it's just about the time, right, Prof, to commission it.
Yes, right. So that is some issues. Okay, maybe I can share some issues. Budget issues. So just now I told you that we got the budget exactly
100%. That's what you applied. Yes.
But still not enough.
You can apply more, Prof.
Yeah, because there are some unforeseen equipment, okay, that we did not plan. We say, oh, now we think we need this now. Okay, so but we actually don't have enough budget. So how to overcome this issue? Okay, operation issue. Okay, the location, is it suitable? Could the design fulfill the objectives? Okay, so these are all because new experience. We've never done it, so now we are going to we hope that we can fulfill or meet the KPIs. Okay, safety issue also. So we have to know about the safety, like using ozone, using the chemicals at a larger scale. So how are we going to handle that? Okay.
Well, that's the reason why people say we will never know about it until we run it.
Yeah. So this is as a researcher and as an academician, one of the challenges is how to commercialize your research. So that's what I'm actually trying to respond to that to that challenge, because Fiza, in life, people ask you what you have not done. Not what you have done.
Why don't you do this? Why don't you do this?
So I'm trying to respond to that. Okay, next one please. Yeah, that is the drawing. Okay, and then that is the factory assessment testing, or called FAT. So we went to the workshop and we tried to run. So we gave our feedbacks when they designed it. So there were some issues like leaking. So most important issues are leaking issues. So for chemical process, you must make sure that it's very tight. So and then the materials is actually materials that can withstand maybe temperature or
not corrosive.
The chemicals. So we have to be very careful. and then also about the height, the size.
All those safety things.
Yeah, so we give feedback to the vendors. Okay, continue. So this is the reactor actually. Yeah, the blade, the impeller, that one is actually we're going to patent. I don't know, now we have shown it, so maybe, but we're going to patent the whole system actually. Yes, because that is one of the KPI. So there are some issues like that. When they designed it, the stirrer is not able to automatically and periodically operate in reversible direction. It's supposed to be one side here, the other side.
Okay.
But they did not do that, so they had to add a time-based control. And then the fiber materials in bioreactor may clog the ozone inlet.
Yes.
So then they have to design the small and add small fittings to prevent this clogging. So there are also some issues during that session.
It will be a major issue if it's clogged.
Yeah, right.
The reactor won't be running.
Okay, continue please. So next one, so this is one of my students. So he went up to check about the reactor, how he should be, where he should stand, how safe it is. So that's how we can give our feedbacks, so that they can improve before they deliver. So this was like about 2 months ago. Okay, continue please. And then for the safety, we were visited by the OSHA. UTM has the OSHA unit. But alhamdulillah, they were convinced with our safety measures, so we can operate the prototype. Okay. So this the biggest challenge because of we are it's something new. It's very bigger in size, the operation. So our planning is maybe not perfect. Okay, so we take time to handle uncertain situation or problems.
The uncontrollable one.
And then of course, during the 2 years, we have this MCO, and then we also had major flooding. So for the ozone generator, it so happened the warehouse where they keep the ozone generator was flooded.
Oh my God!
Yeah, so they had to reorder a new
equipment.
Yeah, the ozone generator was damaged in the flood. Yeah, so that
was very unexpected.
Yeah, and of course now we have the war, so also there are some problems trying to get the material for the procurement and soaring price also. So the budget lari. Okay.
We didn't see this coming, right?
Yeah, right. Okay, continue please. Okay, so how to achieve the goal? So we have, like, I would say that teamwork is very important for them. So we have periodical meetings with our collaborators, with our team, to make sure that at least our execution planning is following the timelines. Okay, and we hope that after this commissioning period we can actually run and get the products that we want.
Inshallah, Prof.
Continue.
That's why people say, Prof, it's kind of like if you want to go far, you need to have a team. But if you want to go fast, then you go alone.
Yes, yeah. So it's very important to have a good team. So now I have a good team. I have the engineer, Dr. Yani. I have a few postdocs. I have colleagues who are helping. Okay, now what we want to do, okay? So what is the next plan after this TRL6, after this prototype? Once we get the prototype, I don't want it to be just like a white elephant. Okay, so we need to talk to investors. So we need to tell them the potential of this product.
We need to
Okay,
market it.
yes. So we have to show that Uzicell is a good raw material. For example, carboxylated cellulose, for cellulose nanocrystal, for bioplastic. So it's a very useful raw material. Okay,
Well,
continue.
it's basically you are turning the waste into something valuable.
Yeah, yes, especially now it is natural fiber. So they are looking for that also because there's shortage of natural fiber like cotton. So if we can, yes, produce a very high quality cellulose fiber from the EFB, so you can imagine what's the market like.
It's going to be, you are trying to finish a very big market problem.
Yes, it's very exciting, right?
It's very exciting.
Continue, please. That's the late Steve Jobs again. We're almost done. Okay, so yeah, so how to enter the market testing? So we have to talk a different language now. not like a researcher.
No more
like
kind of like technical stuff. It's more about marketing.
Yeah, so we have to do that. Very important. Networking is very, very important. Okay, so that's why we are now trying to participate in trade exhibitions to show what is the capability of our OSBIONI 2.0.
I would say like the visibility of your product is more,
Yes.
is very, very important at this
Very
stage.
important, yeah. Okay, continue please. So so we need to protect the technology. That means we have to patent it. We have to also know about the market research, so about the trend of the market, and then trademark the brand, and then also the marketing. So we have to move fast because there are so many also competitions.
Yes, I would say that's kind of like a hard thing about research. Like when you are in a big group, everything moves very, very fast.
Yes.
So yeah, it's kind of like challenging for us as well.
Okay, continue. So that is some of our achievements.
That's a lot, Prof. But already some of our achievement. It's basically that's a lot.
Well, not too bad, but again, you see, I think what comes next is also very, very important.
Very important, yeah. The projection.
Yes. Next slide, please. Yeah, so this is the future development for the OSBIONI. So like I said that since we want to market the technology, so we have to make sure that this prototype at TRL6 is workable, and then we will try to engage with investors. And our plan, okay, next one. Our plan is actually trying to integrate it with the pump and mill.
I see.
Okay, so next one. Yeah, so this is something like the
bigger project.
Yes, the overall. So we have the OSBIONI reactor there integrated with the oil palm mill because we can get the EFP easily, and they don't have issue about how to manage this EFP.
Yeah.
Okay, so and they can get another side income, yes, out of their mills. So it's like a biorefinery. So that is the ultimate goal for this OSBIONI 2.0. Okay, next one. Yeah, so we have to like say we have to find funders. So it's about, we think that from TRL6 to TRL9 we need another about 2 million more.
2 million probably.
So and then we want to collaborate with an oil palm mill, so we can test this technology right there with them. Yes. Okay. Is that the end? Yes. So we've come up to the last slide. So I would like to acknowledge, of course, the grant provider, the MOHE, for giving us this opportunity. It's not easy, but I think we can do it.
InsyaAllah. Doa banyak-banyak.
Okay, thank you.
Okay, so thank you, Professor Insinyur Dr. Nuraisha Saidina Amin, for a very, very informative sharing of her journey from the lab scale up to the prototype level. Well, of course, as a young researcher, I learned a lot from this sharing session. Now, let's see if there is any question from the audience that joined us live via Facebook and YouTube. Okay, so while waiting for the questions to be posted, actually, Prof, I do have a question. So when we were talking about the collaboration or the bigger picture that you showed before about collaborating with the oil palm mill, so is that basically we are specifically targeting on Felda perhaps for this project, or it's basically you are open to any of the collaborators?
Oh yeah, so of course for a researcher like me, it's better that I open first to other mills. Of course, we have an MOU with Felda Takmanda. They are providing the EFP for us now for this research, and they have expressed their interest in collaborating with her. But of course, everything will depend on the outcome of the PRGS results. But we're also very keen to talk to other mills. And also, this technology is only not for EFP, actually.
Yes.
Not confined to only EFP. We have some inquiries from India, from Korea, and they are interested in our technology. In fact, we have a collaboration with a Korean company that was interested. The company was interested in our OZ cell because they want to upgrade it to cosmetics.
Wow!
Yes.
Korean.
So coming back to your question, we are open to any
collaborations.
Yeah, to any. It's not necessarily Felda. So we have like other mills, maybe IOI. That can also come and talk with us. Okay.
And I would say, because what we see here is basically you are specifically using the EFP, anti-fruit punch, from the waste of the palm oil plants. So is there any, I don't know, maybe future plan or whatever that you want to try on another waste from the palm oil as well, with the Oswayoni?
That's a good question, because there are a lot of waste from oil palm. Then EFP is not the only waste, although it is one of the larger waste. We also have tried oil palm prawns, and we get like similar results. But just that between oil palm prawn and EFP, we can easily get EFP. So that's there. Now oil palm trunks probably is also another potential waste to use disposed by you.
Wow. So I guess kind of like, even for me as a young researcher, it's kind of like impressive for you to have this 36 years of career at UTM, and also 12 years of developing this technology from the lab scale to the prototype level. So if you can say kind of like some advice for the young generation of young researchers, I'm one of them. So yeah.
Well, Dr. Fiza, time is different now.
Okay.
So,
Time is different.
You may have, this maybe sound like cliche. Maybe your grandparents have told you that during my time. So also I can see that now we have more opportunities. Okay, because there's no actually barrier to information. You can search the internet, you can go to Google, and you can find out about this process. So as a young researcher now, I think that you should grab the opportunity. So one of the key things is networking. So you have to do network, not only confined just in Malaysia. So go to the region, maybe ASEAN region, because there are also a lot of opportunities in the Asian region, also in US, Europe, Middle East. So we don't know. Okay, maybe our technology is useful for some parts of the world. Okay, but if if just not for here, how to improvise, how to adapt, how this technology can be used for the other parts of the world.
Yeah.
So we have to be very, very open. And also there are other opportunities for funding also. So industries are now more open to collaborate. So we do not depend only on government. In fact, government funding is also very hard to get, very competitive. so the young ones should try to
out of the box, I would say.
and then think also about the spin-off. So that's also important, probably. Yeah, because when you have this spin-off, you can actually generate more technology, more income.
I'll take that note. So, is there any question or, okay, since there are no questions from the audience, now it actually comes to the end of our session. Thank you so much, Professor Insinyur Dr. Nur Aisyah Saidina Amin, for very, very interesting and informative sharing of her journey. Also, I would like to thank UTM Library for having me as the moderator for today's session. On behalf of UTM Library, I would like to thank the audience who joined us for this sharing. Stay tuned for another sharing session that will be conducted by the UTM Library. Till then, stay safe and Assalamualaikum.